Hi guys, Mr. McIntyre here. So just wanted to go through the exam type questions. Question 1 comes down to some of the BODMAS work you would have done from first and second year really. And this tells us that we don't follow left to right. We make sure we do the division first. So it's non-calculator. So it's 27.09 divided by 3. 3 doesn't go into 2, we carry the 2, 3 goes into 27 9 times, 3 goes into 0, 0, 3 goes into 9, 3. So 9.03. So that portion is the divide, which we're doing first before we do our subtraction. That gives us 9.03. That changes 31.4, take away 9.03. That takes that full sum and changes it to this. We now need to just set up an up-down sum, 31.4. Make sure you've got your 9.03, you've got your decimal points lined up. Okay, first thing we do when dealing with any decimals, put in the decimal point, fill any gaps if you want. Okay, you can fill the one in front of the 9 if you want also. So 0 take away 3 can't be done, we need to borrow from the 4, that becomes 10. 10 take away 3 is 7. 3 take away 0 is 3. Again, we can't take away 9 from 1, so we need to borrow from 3. That becomes 11. Take away 9 is 2. 2 take away 0 is 2. Our final answer is 22.37. Question 2, in a similar way, we've got our brackets first. So brackets is B. We've got of here, so we've got our brackets first, then of. So we need to have a look at 1 and 2/3, take away 4/7. So first of all, we can't subtract like this, or we could subtract like this, but we'd end up having to borrow from the 1. So we're best to turn this 1 and 2/3 into a top heavy fraction first of all. So we have 5/3. That's 1 times 3, add the 2, gives us our 5 over 3, take away 4/7. If we create a common denominator, the easiest way is to take the two denominators, so the 3 and the 7, and multiply them. So we get 21. We multiply the 3 by 7, so the 5 has to multiply by 7. So that's 35. It's top heavy, which is fine. We multiply the 7 by 3. So the 4 needs to multiply by 3. So we have 35 over 21, take away 12 over 20. And therefore that gives us 23 over 21, which we know is 1 and 2 over 21. However, we're likely going to stick with using this top heavy 23 over 21 when we bring it up to the original sum. So we've got 3/8 of now 23 over 21. And that comes straight from this calculation. Of in maths changes to times. So we have 3 over 8 times 23 over 21. We want to have a look at any diagonals with common factors. This can be divided by 3, that becomes 1. This can be divided by 3, it becomes 7. So we actually end up with 1 times 23 over 8 times 7. And the final answer is 23 over 56. And that cannot be simplified any further. Okay, question 3 is function notation. So we have an h of t equals 15t minus 3t squared, and we're just looking to evaluate h of -2. So everywhere we see a t, we're going to replace it with -2. So 15 times -2 is -30. Take away 3, and what we want to be careful of here, we've got -2 squared, so that becomes +4. So -30, take away take away 12, should I say, that gives -42. Okay, question 4, worthwhile looking at some of the key points here. The boat is attached to C as a carnival boat, so it's hinged at C. The rod is 6 meters long. We want to hopefully recognize that that's a radius, which is 6 meters long. The length of the arc AB is 7 meters, so we can mark on there that that's 7 meters. Find the angle through which the rod swings from position A to position B. Now, what's always best here is to start with your formula. So length of arc, or arc length, is x degrees over 360 times pi d. So you'll notice that it's an arc length, so it's pi d because it's a portion of the circumference. We've got the radius, so we want to be mindful that r equals 6, so the diameter is 12. That's the first thing. So we know, substituting into this formula, we know we've got 7 from the question there. We've got x, which is what we're trying to find, over 360 times pi times 12. Or sometimes it's easier just to say 12 pi. Okay, now if somebody wants to calculate that and give your decimal value, for example, and have 37.699 or 37.7, that's fine, but that's what you would see in there. I think sometimes it's easier just to keep it as 12 pi. So rearranging this, we want to multiply by 360. So we have 7 times 360. The reason I do that also, I'll maybe do a little bit of the working on the side, is that this whole green section, okay, effectively can change into x degrees times 12 pi over 360. So we have 7 equals that. So if we're dividing by 360 on the right hand side, when we bring it over, it multiplies by 360. That gives us x times 12 pi. Okay, so rearranging that using our algebra, we've got x equals 7 times 360 over 12 pi, or divided by 12 pi. Fire all of that into your calculator. We should have 66.84. So 66.8 will do just fine. Okay, equation of a straight line. We've got 2 points here. So the first job we have is to find the equation of the straight line. Naturally, we're going to start off with the gradient. So our points, first of all, are A, 2, 4, and B, 6, 6. Always get into the habit of x1, y1, x2, if you can look like a 2, y2. So our gradient is y2 minus y1 over x2 minus x1. So we have 6 minus 4 over 6 minus 2. So we have 2 over 4, or a gradient of a half. Okay, that's it simplified. We have our equation, which is y minus b equals mx minus a. And we can choose the a and b from any of the 2 points. Let's just pick 2 and 4. So in this instance, it's going to be the a, this is going to be the b. We have y minus 4. Our gradient is a half, x minus 2. And we can just complete from there. This is a relatively straightforward one, so we can jump through. I'll show you maybe 2 methods for this. We can multiply everything by 2 and end up with 2y minus 8 equals 1 bracket x minus 2, and therefore break the bracket. We have 2y minus 8 equals x minus 2. We have 2y, we add the 8, gives us x minus plus 6. If we divide through, we have y equals a half x plus 3. Now, because it's a relatively straightforward one at this point, we could really just get away with multiplying out that bracket and have a half x minus 1, because this second value is a multiple of 2. So it's a relatively straightforward one, in which case we would have y equals a half x, add the 4 to give us plus 3, and we end up at the same answer. So part A, y equals a half x plus 3. Okay, part B is just asking us to use the equation which we have, which is y equals a half x plus 3, to find the coordinate of the point M. Now, point M lies on the x-axis, so we know y equals 0. It's never gone further off the x-axis. It's the x value that we need to find. So what we're looking to do is substitute y equals 0 into the equation. So what happens there is we have 0 equals a half x plus 3. And all I've done is replace the y with the 0. Now, obviously, when we solve these equations, I would ask you normally to flip this. So it's a half x. So a half x, therefore, equals -3. If we take the 3 over, multiplying by 2, we'll take away the half. So x equals -6. That gives us the coordinate M. We know the x is -6, and we know the y is 0. And it's important to do that. The question says use this equation to find the coordinates of M. Okay, so even if you solve to find the -6, you haven't yet stated the coordinates. So if they're asking for that, then we need to make sure we do that.